In this video, I'm going to continue question number 18 from problems 2.3 Elementary Number Theory by D.M Burton. First, I will do the first part. The second and the third part follow from the first part. See, prove that the product of any three consecutive integers is divisible by 6. We assume that a plus 1 and a plus 2 are any three consecutive integers. We want to show that, or to prove that, the product of any three consecutive integers is divisible by 6. This is what we want to prove. Now look here, for this particular problem, we will use corollary number 2, theorem 2.4 from the book Elementary Number Theory by D.M Burton. Corollary 2 says that if A divides C, B divides C, and GCD of A and B is 1, then AB divides C. This is corollary number 2, theorem 2.4. We will use this one in order to prove the first part, that is 6 divides A into A plus 1 into A plus 2. Okay, see here. 6 is a composite number. We can write it as a product of primes, 2 into 3. Here we see that the GCD of 2 and 3 is 1. See, this one is satisfied. Okay, we assume that this one is A, this one is B. Now we have to check these two. We have to show that A divides C, B divides C. That means we have to show or to check that 2 divides A plus 1 into A plus 2, and also 3 divides A into A plus 1 into A plus 2. Okay, if we can check these two, then using corollary number 2, we are true that 6 divides A into A plus 1 into A plus 2. Okay, so let us do this. See, our first job has been done, this part. Now we check these two. Okay, you assume that your C is A into A plus 1 into A plus 2. Okay, let's check that 2 divides the product of three consecutive integers. To check the first part, okay, 2 divides A into A plus 1 into A plus 2. Here we have two cases. Case 1, see, when A is even, then what happened? When A is even, then this 2 divides A. So in that case, this whole term is divisible by 2. And next, case 2, when A is odd, then what happened? When A is odd, clearly A plus 1 is even. If it is even, then it is divisible by 2. So this whole term is divisible by 2 when A is odd. So what we conclude, therefore 2 divides A into A plus 1 into A plus 2. Okay, now next we check 3 divides A into A plus 1 into A plus 2. If this is to be divisible by 3, then A is of the form 3q plus 1 or 3q plus 2. Okay, where your q is any integer. Alright, now we check for each case. Case 1, when A is 3q, then A into A plus 1 into A plus 2 becomes 3q plus 1, 3q plus 2. this is a multiple of 3, so it is divisible. So it is divisible by 3, okay, because it is a multiple of 3. Next, case 2. What is case 2? When a is 3q plus 1, then a into a plus 1 into a plus 2 becomes 3q plus 1, 3q plus 2, 3q plus 3. Okay, from here we can get 3 outside, then we are left with this. Here we have q plus 1. See again, this is a multiple of 3, so 3 divides 3 into 3q plus 1, 3q plus 2, 2q plus 1. Okay, and now we check when case 3 we have when a is equal to how much? 3q plus 2. Then a into a plus 1, a plus 2 becomes 3q plus 2, 3q plus 3, 3q plus 4. Okay, so from here we have 3 and we are left with q plus 1, 3q plus 4. Again, this is a multiple of 3, so 3 divides 3, 3q plus 2, q plus 1, 3q plus 4. So what can we conclude from the 3 cases? We conclude that 3 divides a into a plus 1 into a plus 2. Okay, now isn't it that we have checked that a divides c, b divides c, plus we have also seen that GCD of a and b is 1. So using corollary by corollary 2 of theorem 2.4, what do we have? We have that 6, which is 2 into 3, okay, what happened? Divides a into a plus 1 into a plus 2, or we say that this term is divisible by 6, okay. Hence we have proved the first part. In the next video we will continue with the second part and the third part.